Hello everyone, welcome to the talk. I think that's my cue to start. For those who don't know me, my name's David Hibbitts. I'm officially a technical account manager over in the UK. I deal with media and entertainment, which is our term for like film, VFX, broadcast, TV, anything like that. Location-based VR, that all sort of falls under the umbrella. And then I help as like a technical point of contact for any of our licensees in that space in Europe. But before I worked at Epic, I worked at the Imaginarium, which was Andy Serkis's motion capture company over in London. So I worked there for quite a bit. I've got quite a history with mocap, and then I came over to Epic. I've also been programming quite a bit, so I've now been helping with some of the motion capture features that we've been bringing into Unreal. And I'm mostly going to just talk about mocap and talk about what Epic is doing in this space. And yeah. So I'm just going to start with like a little story, like Total Recall, the original film. Like Total Recall was meant to be, at least to my knowledge, if anyone knows different, please correct me, but I believe it was meant to be the first feature film to use motion capture. At the time, motion capture was all like sports uses for like gait analysis. I think the company that they used for the motion capture on this was Golf Swings at the time. They'd never done a film, but they wanted to try it specifically for this one scene. So for those of you who haven't seen the film, they need to walk through this scanner, and it's meant to detect for weapons. And as you go through the scanner, you're going to get like your skeleton shows up, and it's going to be synchronized to the person walking through. And they plan to do this with motion capture. Just stick some markers onto the actors, have them walk through the scanner, and then that would just drive the skeleton, and they would be done. No hand keying, everything's great. Sadly, it didn't quite work out that way. The company working on it got quite ambitious, so they set up all of the cameras, and they decided to just do everyone at the same time, like just have everyone walking through. And if any of you have worked with motion capture, specifically optical motion capture, you try and keep the number of people and the volume quite low. The more you get, the harder the problem grows, and it grows like exponentially harder. And this was the early days, so they just threw them in and hoped it worked. So they did got all the data, but they had no real-time preview. They had no way of knowing if this was working. All they could see is what the cameras were capturing. They were like, it looks great. It's like best data we've ever got. And then they went away and tried to solve it and couldn't. It turns out because they had so many people together, the distance between the markers was so small that they just couldn't resolve them into individual markers, and the whole data was unusable. Thankfully, the actual film crew decided to set up some reference cameras, so they at least had video reference of what the actors were doing, and they ended up hand keying every skeleton. Like it was roto and key for all of it. And it's just sort of, it's an interesting story because like right from day one with motion capture, specifically in film, like not having that real-time preview hurt. Like you never quite know what you're going to get. And now we're reaching a point where it's sort of expected that you're going to have that real-time preview. And the stuff that we're doing at Unreal is pushing the quality of that preview way higher and allowing you to do things which you just wouldn't have been able to do before. There's a really great article on Total Recall on fxguide, strongly recommended. Specifically, I forget what the section's called, something like the perils of mocap. And it's just some of the original people who worked on Total Recall talking about what happened, and specifically that motion capture section. But as I said, that sort of, it gives you a little glimpse at what was going on and why real time is so important. Now, like fast forward to today, why did that go? There we go, current uses. You never saw that. I'm totally professional. But yeah, so like fast forward to today, and like mocap has been used everywhere. I'm going to get into specifically what we're doing at Epic to support all of this, but I just thought I'd go through a couple of the use cases in a couple of different sectors, just for maybe if you're not as involved with motion capture, you can see what's happened. So like film is the obvious one. Like film is probably where most people have seen motion capture. They've seen Golem. They've maybe seen like Planet of the Apes. It's mostly Andy Serkis, but But yeah, so that's probably the most visible one. So this is actually from some previs for a film. And bonus points if anyone knows the film. I'm seeing blank looks. If you get it, I will be very impressed, because I had no idea. This was from the new Blade Runner film. So this was previs that Framestore did for it. And this is sort of how they're working. So these two people, I think I've got a better shot of them, they're in motion capture suits. They're on set in Framestore's office in London, and they're moving around. They've got sort of virtual cameras moving, and they're planning out the sequence. It doesn't look like the film is finally going to look in the end, but it looks relatively close enough. Like, they can make artistic decisions right at this early stage. Whereas before, you would have to film and sort of imagine what it would look like and sort of hope that you were capturing the right thing. Now they can see how it's going to look like. How will those props look in the background? How does the framing of the camera set up? So pretty much all of the previs companies that I know of, at least the bigger ones, they're all starting to use like real-time engines. I mean, mostly it's Unreal, but as I say, just having that the real-time capabilities is really helping just make these decisions sooner. There's so many films in the past where a director has made a choice on stage without full information, and then the VFX team has had to spend months fixing that later down the line. Like, if you ever want to make a VFX person cry, just mention the phrase, fix it in post. Like, it is, people have lost, as I said, weeks and months of their life to that phrase. And now we're bringing that sooner. But it's not just film. So like in like the games uses. So this was a VR game which released, I think about a year ago, maybe a little bit before that. It was one of the early Vive games. It was called Call of the Starseed. And what they did, they're actually in Vancouver, they're on Vancouver Island. They had a motion capture suit. So I don't know if my mouse will work on here. It does. So like these straps here, this is an inertial motion capture suit. It's great for, it doesn't give you any positional data, but it gets you the pose of the person. So they know like what their body is doing. And they had their actors in a Vive headset with this motion capture suit on, and they had them acting out the story, but they were in the world that they were meant to be acting in. They could see the other characters, they could see the environment, and they could react appropriately. And this let like a really small team create like hours and hours of animation like very cheaply. I think they only have like 1 or 2 animators at the time, and they were able to churn through so much because they were using mocap, and specifically having it real time, having the actor in VR and being able to see it. They gave them like floating virtual teleprompters, and they put quite a lot of work into it, and the result was really well done. There's this guy who, if you were at Real Time Live yesterday, you'll have saw one. So this is Kite and Lightning, that's Corey, and he's been doing some work again on games and for getting animation into the game. They also don't have a huge amount of animation resource, but they also have a requirement for lots of characters, lots of animation, but they're able to now do it a lot quicker. In this case, he's using an inertial system, but this is an XN's suit. But he's just got an iPhone 10 just strapped to his face through a bike helmet. And it's really compelling. Like, if you haven't seen this, they've got videos online. I strongly recommend checking it out. If you just look up Kite and Lightning, you should find it. I imagine Creepy Baby Mocap will also get it. But yeah, so it's really quite nice. And again, you're bringing these, what used to be huge film companies, down to a level that anyone can, well, I say anyone, but like relatively anyone actually, yeah. So like smaller indie companies or smaller development studios where they don't have this traditional resource, through the use of real-time mocap, are able to like go to places they've never quite been able to do. We've seen it in like location-based experiences. So this is from The Void. So the Void are a company who specialize in location-based experiences. This one in specific is their Star Wars one, Secrets of the Empire, which came out fairly recently. This is now at like every Disney park that I know of. I think it may be in Paris, but it's definitely all the Disney parks in the US. And the premise is, so you and 3 of your friends, you get strapped in, you have a backpack PC, the vest has got sort of various mocap sensors on it as well. And then you put your VR headset on, and you become a stormtrooper. You're immediately put into the world of Star Wars. You go through the experience, and they physically built the set so that if you see a wall or if you see a prop in virtual reality, it's really there. You can pick it up. Like, they ask you to go through a door, like, you'll feel the door frame. They ask you to pull a lever, there's a physical lever you pull, and just giving you that other sense of immersion. But again, that's done through motion capture. They have an OptiTrack system on the ceiling, and again, mouse time. So like here, there's LEDs embedded into these plates, and then there's LEDs on the headset itself. And it's using those for tracking. The infrared, you don't see them, but the cameras do, and they're able to get this sort of compelling experience. Whereas traditionally, like, the VR is contained to quite a small space, they're able to go much larger. And it's all real time, it's interactive, and it's social because it's with people. Like, theatre, I have a little bit of a soft spot for this, just because I've done some work here in the past. There was a really cool project at Tribeca this year. It was called Jack Part 1. It's by Baobab Studios over in France. And it was Jack and the Beanstalk, except it was a mix of VR and motion capture is how they did it. So the woman in green there is the person going through the experience, and she's just got a VR headset on and a Leap Motion. She can see her hands, but only if she's looking at them. And that's fine, that's all she really needs. She needs to be able to walk around and interact with things. But then you have this actress who's in a motion capture suit, and she's going to be playing every single character in the story. So it's Jack and the Beanstalk, but it's like anthropomorphic. So your mother's a frog, for example, in the story, because that's how they decided to do it. But yeah, so you put your headset on, and like the very first thing which happens is your mum comes into your room, you're playing Jack, and she's like, clean up your room. And she gives you, oh shit, that slid. She gives you a broom. Like, she will just give you a broom and say, clean your room. And it's a physical broom, and you have to literally pick it up and sweep. And otherwise the story won't progress. But because it's a real person, if you refuse to do it, she'll keep talking to you. She'll tell you off. There's interactive, rather than being limited by AI, where if the user goes outside of what you've trained the system to do, now you've got a real person. They can respond, they can have this interactive dialogue. And she'll play other characters throughout the story. And again, it's all because they've got that motion capture. Like, her setup, she's got, so it's a standard optical motion capture suit. You've got the markers all over the body, except she's got a face rig as well. So this is Dynamics or Dynamic XYZ. They do real-time face capture. So her face is being captured along with her body, and using Manus gloves down here, she's got fingers as well. So you've got a compelling person now. You have body, you have fingers, you have face, and she's able to talk to you and have expression and have direct interaction with you. And at the moment, like, this is expensive. This is like, you can only really do this at things like Tribeca, because you've got one person to one actor to like a couple of technicians to a whole stage. Like, you're not getting the volume through that you would need for this to be a commercial experience. But as these sort of smaller art installations, as I said, it's really compelling. On a larger scale, there was this project which I worked on, the Imaginarium, and this was The Tempest with the Royal Shakespeare Company. And it's a little bit overwhelming in that image, but so here we have an actor, Mark. Mark was playing Ariel, and for those of you who don't know the Tempest, Ariel is a spirit. He's been captured by this guy over here, who's Prospero, who's the wizard in the story, and he's got Ariel enslaved as his servant. But because Ariel is a spirit, he has like magical abilities. He can change form, he can fly, he can burst into flames. You can't really do that with the traditional costumes very easily. There's lots of ways to suggest that's what's doing, but he can't physically burst into flames. I think health and safety would have issues. What we were able to do is his suit is actually a motion capture suit. And we've got these sort of gauze tubes which descend from the ceiling, and there's various other gauze screens which will be around, and he can be projected onto that, and you get sort of this sense of a hologram. You've got projectors to the floor, projectors of himself, so that's his avatar, which is being projected onto the screen. And he can drive that in real time. As he's performing, he's puppeteering this character. And that character we can set on fire, we can make him fly, we can turn him into a harpy. And all of it, that was sort of his suit without all the decorations. It was just an inertial mocap suit, the same as what we saw in some of the earlier uses. But because it's inertial, because you don't need to see visible markers and have cameras to track it, he was able to hide that under the costume. Like when we were rehearsing it, it was like that. He was in an optical suit, he had a big camera rig. It was like, we weren't going to be able to get away with that on stage. But then once you got the costume team involved, like that was his mocap suit. You can't see that anymore. That's all real time. That was all being driven through Unreal and projected back onto stage. I think we had 46 projectors for that project. It was a bit of a monster, but it turned out really well. It got really good reviews. And these are all different use cases, but they're all sort of, they exemplify what you can do with real time. Like no longer is mocap just you record it, you get the data, and then you use it later. You can now start interacting with it. Yes, it's really good for previs, where you want to just be able to see it earlier, but also, as I said, you can then interact with it. You can have cameras moving, you can make these decisions, you can make these experiences which are immediate. And it's something I'm sort of quite passionate about, is having that immediacy and that interactivity with data. So one of the features I've been working on at Unreal is it's called LiveLink. And the concept of LiveLink is, well, actually, that's what we say on the website. Like if you go to the docs page, that's what we describe LiveLink as. So the purpose of LiveLink is to provide a common interface for streaming and consuming animation data from external sources. For example, DDC tools or mocap servers into Unreal Engine 4. It's designed to be extensible through Unreal plugins, allowing third parties to develop new features with hopefully no need to make them and then maintain engine changes. All of that is 100% accurate to what LiveLink is. It doesn't really say why that we made LiveLink. And like we had a diagram, and it sort of gives you a nice overview. And again, all of this is 100% accurate data, but it doesn't give the reasoning for it. And the reason LiveLink is a thing is anytime you want to get real-time data in, whether that's motion capture data, whether that's camera tracking data, whether that's you want to animate in Maya and stream directly into Unreal as a real-time viewport, like everyone writes their own way of doing that at the moment. And then they want extra features, they want support, but there's no common point in the engine for that support. Like just nowhere can we add something and it will affect someone else. Like for example, some of the solutions I've seen in the past require you to make a custom anim instance for the anim blueprint to be able to control your character. Except what happens if that's your face mocap, but also your body mocap requires a custom anim instance? Like which one do you use? How do they talk together? And you start running into these issues very rapidly. So what we did is we've made this unified point. And LiveLink is just an interface. You can stream your data however you want. Your data can be pretty much whatever you want, as long as it's just some transforms in a hierarchy, it's some floating points for like blend shapes or parameters. it can happily just come in through LiveLink. You stream it however you want and just expose it to the interface. I've helped like Dynamics do their integration, and it took them 2 days to convert their plugin. About 1 day to actually do it, and then about 1 day to test it. Just because, again, it's this thin layer. But once we have that thin layer, once everything is coming through our system, it gives us this common point that we can start adding features. So at bare minimum, we give you a unified way of driving a character or driving some props in your scene. That's useful, that's nice. Actually, here's some of the, it's like consistent, common. Like, there's an easy way to actually get that data out onto a skeleton, and that's useful, but then we can go further. We can start adding the ability to synchronize multiple motion capture sources together, so your face and your body stay synchronized, and you're not getting issues where maybe the eye direction isn't quite matching up because the head rotation doesn't match your eye direction anymore. We can start looking at how do we retarget, how do we blend all this information together. And it's really powerful. And even at this early stage, it's in engine at the moment, it is usable. We have quite a few sort of partners who have integrations. The Blender one in particular I'm still working on, but it's in a work in progress form. But the rest of them, these are all things you could get today and you could start working with. And there's way more coming. Pretty much any mocap provider or any camera tracking provider, if I know of them or I've seen them, I've probably harassed them about LiveLink at this point. We're trying to get everything common. We want a user to be able to be like, build a system, which maybe in their office they're using an inertial suit, but then they go away to a film set and they've got a full-on optical system for a shoot. They should just be able to swap and say, oh, my data's coming from the optical system now, and that should just work. They shouldn't have to rewrite their project. They shouldn't have to do all this extra work. And that's what LiveLink is hoping to provide. So in the spirit of optimism, I've decided to do a live demo, and this may or may not work. Hopefully it'll be fine. If it breaks, real-time, mocap. So let me quickly switch to duplicate. Okay, close that and restart that. So for this one, I'm just going to use so Perception Neuron. They do a sort of relatively inexpensive motion capture suit. Started on Kickstarter, and now it's now they've sort of got a second version of the early Kickstarter hardware, like the budget one, which is about $1,500, and then now they've got this. They're calling it like the Neuron Pro, which is what I'm going to be using here. I don't believe it's out yet, but they were kind enough to lend me some hardware for this. I was going to do a full body for this, but it turns out just practicalities of trying to line that up for a talk, a little bit ambitious. So I'm just going to do a single arm. So in this case, they're just straps that you put on. So I'm just going to quickly put those straps on and then show how real-time mocap will work in Unreal. And then as I'm going, you'll probably see some issues with how to do real-time mocap. And those are what I'm going to talk about for what are our upcoming plans. What are we going to be working on next inside of Unreal? And how are we going to keep pushing this forward? So I need one on my bicep. And which one is this one? Get the hand. And that's a wrist. Okay, so I'm just using 3 sensors for today, which is just going to be my arm. So I will just hit connect. My screen is duplicated, good. It should find the sensors. Yes. So it's only found the 3, and it's, as you can see on the robot at the right, you can have the whole body, but I've just set it to be single arm. And if you notice, it's horribly broken, the robot. If you zoom it in, just so it's a little bit more visible, yeah, that arm is not doing what it should do, so I'm just going to have to quickly calibrate. And next. So it's just stand with your arm down, and then stand with your arm at the side. Okay, good. So I have an arm. As I said, it's like immediately you've got some real-time motion capture. But it doesn't look like sort of what you expect. You don't have your set, you don't have your right character. This is just the raw mocap data. There is one issue with this particular one-arm thing. It doesn't know where my chest is, so if I turn around, I'm just going to go straight through this character. So, but it works okay. Like you can even see as I'm moving my mouse. And then what I'll do is I'll just start that streaming. Okay, yep. Thank you. So I'll move on to this one if I'm wandering around. So that should be started streaming. Here I am over in Unreal. I already connected, so shush, you didn't see that. So this is the live link panel. If you're looking for it in Unreal, it's Windows Live Link. You may not see that by default because the plugin may be turned off, in which case settings, plugins, animation, there's just this live link plugin down here. If you tick that on, this window appears. And I actually have the Perception Neuron plugin. They delivered this to me last week, so this is like very early. But it's a good idea of showing like how direct into Unreal mocap would work. So if I just connect that here, you'll see that it's connected, and I've got this character char00, which is what the Perception Neuron stuff calls its characters. If you had another one, it'd be char01, etc. And if I open, why is that not driving? That is slightly worrying that that's not streaming. This one should be working. I'm going to go for the tried and true restart the project. Yeah, so the idea is I can stream that into Unreal. And this will work really well, but I'll be onto the same character. Like, it'll be able to drive that character fine in Unreal, but the skeletal hierarchy matches. And so it behaves fine. The problem we're going to hit, and let's see if I can make it hit that problem. Is this neuron connect? It's not streaming. It's worrying. Broadcasting. Oh, whoops, my bad. There we go. It's streaming now. So yep, here's my animation blueprint. And there's the same robot that we had inside of their software, Axis Neuron, inside of Unreal. And it's just a single node in the animation blueprint. It's that live link pose node over there. And that's a common thing. So if you have any live link source coming in, they will just show up as a live link pose. This only works if the skeletons match. And we have some tools for working around it when the skeletons don't match. So if we have, if I make this full screen, if I click on there, you'll see at the side in the properties, there's this retarget asset. And the retarget assets come in two flavors. There's a remap asset, which is a blueprint thing, and they can do very simple operations, basically mostly with the name. For example, if you want to put bone A onto bone B, you can change that in blueprints. And I'll actually open it up, and I can, because that's pretty much what this one does. Here's my remap asset. Whoops. And you get some function overrides inside of the remap asset. This one's already overwritten one called get remapped bone name. That's the name of the bone coming in from LiveLink. That's the name of the bone you want to drive inside of Unreal. And in this case, they're just splitting on double colons because they've got a prefix and they don't want the prefix, so it's been stripped off for Unreal. And that's all it took. And now the names match and it knows to do the right thing. If you want to do something more complicated, like we have a C++ version, which is the actual retarget asset. And at that point, you just get a single function, which is, here is a frame of LiveLink data, give us a pose on this character. And you can do whatever you want in the middle of it. And that's open and that's available. So we've worked with iKinema, who do like retargeting and IK solutions, and they now have a version which supports LiveLink. So they can use their systems and create this retarget asset, and then you can take advantage of all of their retargeting systems inside of Unreal, all coming through this common LiveLink. But in this specific case, like, I don't have iKinema on this system, but I want to drive a more complicated character. For that, what I can do is, if I just remove the LiveLink source, I can use Motion Builder, which is an Autodesk product. So Motion Builder is really good at retargeting. Like, that's pretty much the main thing about it. Generally animating characters and doing things with characters, but the retargeting in specific is pretty much an industry standard at this point. There's a lot of people still using this, even though it isn't massively supported by Autodesk anymore. So this is Twin Blast. He is one of the Paragon characters, and I want to drive him with that ARM data. So I will bring in the, change the settings on here, but I can stream now into Motion Builder instead. It has to be TCP for Motion Builder. There we go, create, and go live. So that yellow skeleton is now going to be me. That's my arm, and again, you've still got all the problems of not knowing where the chest is. But if Motion Builder has this concept of characterization, and characterization is you T-pose a character facing a specific direction, and then you start knowing what all the offsets are. And you also know what bone maps to what bone. It sort of maps you to a generic human. And if two things are mapped to the same generic human, well, it knows that that one can drive that one. And in this particular scene, you can see it's called Twin Blast Characterized, because he's already been characterized and set up, which means I can go into his character and say, you're being driven by a character, by the robot, and go live. There we go, Twin Blast. His arm moves. Still no fingers, but hey. And I have this UE live link. The blog for this actually went live maybe an hour ago, but this is now publicly available for streaming into Unreal. So I do have a talk at the booth tomorrow on how to set up the Motion Builder streaming if that's of interest, but because this is a more general mocap talk, I'm just going to fly through it. So I'm just going to stream him as Twin Blast. Turn that online. And the most important thing with Motion Builder, always refresh viewer, otherwise it will just die as soon as I alt tab. Over here, add message resource. So the same process as before, I'm adding a live link source. In this case, I've now got Mobu live link, and you see that there's two things. There's editor active camera and Twin Blast. I didn't actually add editor active camera. That's a special one, which is the viewport camera from Motion Builder. So if I want to synchronize viewports, I could do that. Now that that's all connected, let's go into Twin Blast characters. And here's one I made earlier. Twin Blast. Please load. There we go. So we have, let's zoom in a little bit. So there we go. So we have the Twin Blast character all streaming in real time. And his blueprint is a little bit more complicated than what we were doing before. There's still that same live link pose node that we had before over here. But there's all this blend by layered blend per bone. And the reason for that is Twin Blast explodes without it. He gets flying guns. If you look at Twin Blast skeleton, that's how he's rigged. His guns are on the floor and his hands are out at the side. So there's a bone between his hand and the guns. And because we have no animation data on those bones, they're just going to stay at that length. So his arm moves and the guns are going to fly. He also has a flying grenade somewhere. There we go, flying grenade. So what I'm doing here is I'm blending his idle pose. Like this is his idle, if I feed that in. So I'm taking that pose, and I'm stealing the hands from them. So I'm blending everything from the fingers down, and the gun and the grenade is going to be coming from his idle. Everything else is going to be coming from the motion capture. And that's kind of the really powerful thing of having live link and having real-time motion capture is you don't just have to use the mocap data. You can use additional things. If you want to be triggering particle effects, if you want to be having real-time physics on top of things, like if the moment this is running in editor, but if I put this into like simulate, like he's got physics on his jacket, like as I move my arm, it will waft. You can start getting these immediate decisions on like how is his coat going to fall, how is like maybe I've got something dangling, like I'm holding a chain or something like that. How will that move? How do I want that to move? Like all of this becomes immediately available. And it's a little bit boring just having the rest of his body standing there. So like I could, this one. So at the moment I'm just blending from his root. If I look at his arm, upper arm, that's what I'm driving. So I only want to drive from there. At the moment I'm driving his whole character. So I can just change that to upper arm, boom, and hit compile. And so now he's in his idle, but the arm still works. Or I could put a more interesting animation in. And there we go. You have Twin Blast in his run state, except now, boom, boom. Like, I can drive his arm, and I can layer it, and I can start creating this sort of whole layered way of approaching the character. If I want to just say, like, oh, what does, like, his, how do I want him to hold his gun? Do I want it like that? Is he, like, one of those people? Is he one of those people? Is he, like, one of those people? Because why not? I can make those decisions. If I'm an animator, like a lot of animators, especially like facial animators, they have a mirror next to their desk because they want to like try out a pose and see what it looks like and use that as reference. This is just sort of a level up. You can try that reference on the character. You can, I say, this is the whole message of real time is it's immediate. You can make those decisions straight away. And you can see it in context. Like if I go to, this is our sample map from the Paragon assets. Let's go done save. And we'll hit G so that stops flickering. There we go. I'm going to have to put down the microphone for 1 second because I need to actually no, I can do it right-handed, I think. There we go. Trying to navigate Unreal with one hand, really difficult. But yeah, now I've got an environment, and I can do the same thing that I was doing before, is we drag a character in, boom, there we go. Immediately, we can see him in the level, in context, and like maybe I want to see what happens if I have, where's copy? I'm just going to use keyboard shortcuts. Like I can start layering them. I actually worked on a music video for Coldplay where they had a load of monkeys dancing at the same time. And it was just one dancer, and they just copied and pasted him. But I said there's an immediacy to it. There's almost a sense of fun. There's a sense of like playing with the data. And that's what I really like about how mocap is changing. It's available to so many more people, and it's so much more interactive than it's ever been. And we're going to keep on that. So that's going to be my demo portion. I'm going to swap back to my slides now. Because I say there are some issues, and like some of the things I've talked about, such as retargeting, you can do it with third-party solutions, but maybe you don't want to be using Motion Builder. Maybe you don't want to be paying for an iKinema license. They're not necessarily cheap things. So we have plans, and I'm going to sort of drill into them. Can I swap back to this microphone, please? watch Twin Blast arm break while I can't turn off. Unfortunately, you have to hold them for about 10 or 15 seconds, so there's going to be a lot of me pressing buttons. Whee! It still kind of works, even with just like the sensor in the air. Okay. So there we go. Back to this. So I said, there's a couple of things missing at the moment with LiveLink. And these are things that we're actively working on at the moment. Some of these we've kind of solved internally, and we'll be coming to the next version. Some of these are a bit harder and a bit more long-term. So sync is, actually, we'll start at the bottom. Like retargeting was what I was talking about. And retargeting, I said, it's a hard problem. It sounds quite easy on paper. It's like have one character drive another, but their limb lengths may be different. The shapes, it's not going to quite match up. What if you have someone with long arms and you've got quite short arms as the actor, and then you reach to pick up something? Well, you could tune that so the hands go into the same place. Maybe the long arm ones bends their arms slightly more to reach the object. Okay, that's fine. But now there's going to be situations where, like if you put your arms down at the side, the tall character's going to be like this. Just staying with the microphone. Like, it's going to pull its arms up. It's going to look wrong, and you're going to have to work around that. But then if you go the other way, so you're matching the angle of the bones, well, now if I try and do this, my hands are going to go through each other because the arms are it's making the right shape, but the limbs are longer. The hands are not going to line up anymore. So all of these decisions have to be made. And there are tools for it. So as I said, Motion Builder, iKinema, they all have a really nice suite of tools for working with it. And there are other ones out there, like Reallusion make iClone, which has all these features. But we kind of want people to stay in Unreal at least as much as possible. So we want to add some basic retargeting tools. Maybe it will, at the start, it will only be for a human character, well, a human actor to a human character of relatively the same proportions. Maybe it won't have all that clever extra stuff. But if you want to drive something like what I was doing of, let's take this robot and put it on Twin Blast, you should be able to do that straight away in Unreal. And that's sort of where we're working towards. But still keeping that flexibility that if you do need the power, then you can access those through the retarget assets. You can still use iKinema. You can still use iClone. It can all just come through. And if you have your own system, well, you could add integrations. Like we want it to be open. We don't want to nail you down to one specific way of working. That's kind of the long-term one. There's no hard and fast plans on when that's coming. But on the next slide, I'll show some of what we've been working on, which will be making its way into Engine. Since I'm going in reverse. Recording. At the moment, if you've ever used Sequencer Recorder, like if you try and record, the recording works great, except it will sample at the frame rate of the game or the animation that you're playing. And your mocap could be running significantly faster. You could have mocap running at 120 hertz, but you're doing a 24 hertz project. You're going to be missing so much of the data. You may get tearing or stuttering. There's something called the Nyquist limit, which is all about sampling data. And it says you have to be twice the frequency to be able to accurately sample. And in this case, we're like a fifth. So you are going to lose things. What we want to do and what we're working on at the moment is we actually have a full buffer of all the mocap data you're sending to us, all that animation data. So we want to be able to record that directly, and you should be able to get the full data, barring any packet loss from however you've sent the data. But if the packet arrives at Unreal, we should record it. That should be a key on a track, and that should have all the timecode associated with it so you can line things up. And that kind of leads into the first one. We've been working a lot on sync. Timecode is just a way of knowing when things happened. At its core, it's a really simple technology. It's a number which gets higher over time. But actually getting everything to synchronize correctly, to fire on exactly the right time, it's really hard, and people have been working on it for decades, and we're pretty good at it now, but there's still issues. But we want Unreal to be able to support that. So in the last version of the engine, we switched over to make timecode a real thing in the engine. Like, we now have a concept of frames. We now have a concept of like accurate integer time. Before, we just counted in seconds and hoped it was good enough. And for games, it is. But when you start getting into these more stringent requirements, it stops being that. And we added like this synchronization manager. And it synchronizes, at the moment, video and also the engine's render. So you can lock the engine to render precisely at your synchronization signal. If you want the engine to render at 60, it will be precisely 60. But LiveLink isn't part of that at the moment. But it will be, and we're doing that work at the moment, which will mean, say you have face data coming in, say you have body data and hand data, all coming from 3 separate providers. But maybe the face takes slightly longer to process than the body. Maybe the hands are really quick. Well, you need to align them at some point, because otherwise you'll end up in situations like your neck rotation comes from the body, but your eyes are coming from the face tracking, and then the eyes are not going to stay locked on a person. Like, if I focus on someone and turn my head, my eyes are going to stay tracking them. But if that data is not aligned, it won't. And you get this really offsetting thing of it just looks wrong. And people are really good at knowing when motion looks wrong. They can't always tell you why, but they can always tell you it's wrong. So we want to make sure that doesn't happen, make sure it's synchronized, make sure any mouth movements you're computing matches the audio. So sync and recording are probably going to be relatively soon. Hopefully the next version. I can't hard promise that because it depends on when things get finished. But hopefully that will be the next version. Retargeting is a more long-term goal, but I just wanted everyone to be aware that we are working on that. That is happening. So this is kind of tangential to mocap, but it's also really cool, and I wanted to talk about it. So control rig. If you've ever worked in any DCC with animation, you'll know that you don't animate each bone on its own. Maybe for tweaks, but generally, like, if I wanted a character to do this, I wouldn't go, okay, I'm going to move that to there, then I'm going to move this. I'm going to grab something at the wrist, probably, and there's going to be an IK chain, and the arm is just going to respond to what that thing moving. And at the moment in Unreal, we don't have that. All we have is drive each bone directly. And that's fine if you're using like mocap where your data is coming in per bone. But if you want to then work with that inside of the engine, it's a pain and it's not really usable. So we're working on this system called Control Rig, which is basically the... can we have the music reasonably low for this, please? It's just some ambient background. So Control Rig is kind of what I was on about, is having those things that you can pull around and having IK chains, having orient constraints. So in this example, we've got like a robot arm. This was done by Lena, one of our lead animation programmers. And there we go. So as you start pulling it around, you'll see that it starts responding how you'd expect. She's going to have something at the top where when she moves it, the whole arm is going to respond to it. But then she'll also have a separate one which controls the orientation. And of course all this becomes animatable in sequencer. You can start keying these changes, you can start working with them. And it becomes a much more natural way. And it doesn't seem immediately apparent why this should be a part of motion capture. But if you think about it, the data that you're getting in from motion capture can be treated as inputs to this. You want to be able to make things like this hand should be in the same position as this hand. This elbow should face the same direction of the character's elbow. And you can start layering those constraints and feeding those inputs from your mocap, and you can get retargeting. And it just sort of falls out of a system like this. If you can drive this at real time with any arbitrary data, it becomes really powerful. In this one, they're copying the animation from the hand to drive the gauntlet. The gauntlet is just a mesh with its own skeleton, and the hand is a mesh with its own skeleton. But it's using that hand's skeleton to drive the gauntlet's one through some constraints. And I think there's an image in a little bit which shows it quite nicely. But I'll let it play through. But yeah, so she's got this pose, and if you just put the gauntlet onto it, her fingers are going to start penetrating through. Whereas with control rig, it's going to drive. There we go. If I pause that here, yeah. If it's disabled, the fingers penetrate. If it's enabled, it will move and it will respond. And there's very little difference between having a gauntlet match a finger's rotation and having a mocap skeleton come in and drive your final skeleton. Like, there's a lot of work on the interface side for how do you get that data in, how do you work with that. And so this is very early stages, and we're like, some of the functionality is there, but we're missing huge swathes of user interface, but it's coming, and this is all stuff we're actively working on, and it's stuff that we care about. We want to get this working, and we want to do this right. So I think I'm pretty much out of time. I'm going to go to questions, but that should a general overview of like what's happening with mocap at the moment, what we're doing specifically at Epic. But yeah, if anyone's got any questions, either ask them now or feel free to come and grab me afterwards, and I will happily talk anyone's ear off about mocap for as long as they want. So, thank you. Has anyone got any questions? Have a cue. It's a microphone. So yeah, just talk into the cube, and you should be.
What's the latency between data coming out of the capture volume and appearing on the Unreal frame buffer?
So it really depends on how you're streaming it. I'd say LiveLink is agnostic to the way that you stream your data. Like if you're on the same machine and using like an inter-process communication, it's going to be relatively low. It's almost negligible. When you're streaming maybe from one continent to another, it can be quite high.
Not quite that far.
So it really depends on how you want it set up. Generally, the way I tend to do it is just through like a TCP or UDP socket, just on a local network from one PC to another. And it's on the order of like 1 or 2 milliseconds kind of thing. More of the time, like latency-wise, is going to be if you go through like Motion Builder, it's the processing latency for the retarget is going to bite you way more than you are. And for one character, it's, again, kind of negligible.
I was going to say,
like
how many characters?
10. On Unreal side, I said, the limitations is more, can you get the data to us? Like, if you can send the data fast enough, we can show it fast enough. But if you're using really heavy characters and lots of real-time physics and lots of real-time cloth, well, it's going to be slow to evaluate. So there isn't really this is the magic number. It really depends on how you're setting it up. But I've done like, I don't know, in my tests, I streamed through like 20 or 30 characters. And it was
unique.
Yeah, unique characters, and they were behaving fine. But that was pre-recorded data being streamed into Unreal and then played back. For Fortnite, like we animate hundreds of characters at the same time. So the system can keep up with it, providing you're a little bit smart on how you organize things. Yeah.
Thank you. So are there tool sets out there for optical motion capture without the suit for more of like a public user experience?
Oh, so when you say optical, like from a camera rather than...
Yeah, because I know there's a Connect plugin.
So I don't know if there's any LiveLink support for that. Actually, there is one. God, what's his name? Brekel isn't it? Like Brekel. He makes a piece of software which is, I think it's called like Brekel Studio, which is can take multiple Connects connected to it or multiple depth cameras just generally, and it will reconstruct a skeleton. And that does have a LiveLink plugin that will just stream into Unreal in real time. So that's the only one I know of, which I've helped with a LiveLink plugin. But I said this is public, so they could have made one, or they may have the older style custom plugin.
Yeah.
But I say something like that. That's the only one I know of, which is relatively feature complete.
Thanks. How would you clean up your data once it's recorded by the sequencer recorder, so you had the 120 frames per second data?
I said at the moment, you struggle. Like we do have a curve editor, and you can sort of mess with keys, but it's Unreal's not really great for tweaking animations at the moment. Again, it's one of those things we want to get better at. But at the time that Unreal was, for like decades, it's always been you animate externally, you clean, and then you bring into Unreal, and then Unreal just uses the animations. The animations were never sort of designed to be authored in Unreal. And I'd kind of stick to that at the moment. So I would record the mocap data externally and then clean it and send it in. But if you're doing previs, if you're doing camera moves, you could be doing that directly in Unreal, and we want you to be doing that in Unreal. But as I say, a lot of the tooling for that is still in development. When you don't, can you pass the cube over to that side? Just because otherwise it's going to live on that side for a little bit.
Sure.
It will come back, but I saw a hand somewhere over there. Yep. Just throw it. It's soft.
Yeah,
I
I passed down a couple. Here.
Coward. I'm reasonably sure we're insured if you hit him.
So you mentioned how the live link also stream like camera data.
Yes.
So I was wondering, other than like cameras and animations, have you tried like streaming like other data, like I don't know, particles or something like that?
So I've played around with quite a few different sorts of data. I said generally it all boils down to, can you represent your data as transforms and floats? If you can, it works quite nicely, actually. I said cameras are an obvious one because you can send through like all your focus data as just curves. But then I've tried lights, they work as well. But I've been talking to some companies, like one of them wanted to do like, trying to think what I can say without breaching NDA. Some big industrial equipment and stream through sensor data on them into Unreal to do like real-time previews. And like so you could have like a 3D diorama and it can accurately reflect state of the sensors. And all of that is possible and it all works. LiveLink doesn't particularly care what your data is. It just needs to be transforms, floats, and maybe some metadata and some strings. Like, as long as you can represent that, it should work fine.
Second question is, have you tried like using like a third-party retargeting and live streaming it into the engine? And have you noticed like there's like a lag or performance?
I was going to say, so that's what I
issues?
did with Motion Builder. So Motion Builder was the third-party retargeting, and then it streamed in. And I said the issue there is just like, there's not a huge amount of latency with one character because these things are quite efficient. When you go up to say like 10 characters, you're going to start to notice it. You're going to be starting to be a couple of frames behind. And that's where that synchronization stuff that I was on about is going to be really important, because maybe your body is going to be delayed from the retarget, but then maybe some other source of data that you want it to line up with won't be. So you want to make sure your Unreal renders with the right data for all of the different bits of data that the scene relies on.
Thank you.
Yeah, no problem.
Okay, I got 3 questions.
Okay.
Pretty short. Are there any works on quadrupeds and recording data for that, like dogs or whatever?
So the stuff for quadrupeds would all be however you're capturing the data and however you're targeting. So at the moment, there isn't anything specific. We just treat, in the engine, quadrupeds are just a skeletal mesh, possibly with some blend shapes. Mm-hmm. We don't have anything special for them. Like, for example, this control rig stuff that we're doing, it just works on skeletons. Mm-hmm. So you would be able to use those features on a quadruped, but it would kind of be on you to be able to capture that data and know how you want to work with it. We're not, at least at the moment, planning to do any like turnkey solutions. We're planning to give tools and feature sets that you can build the tools that you want to be working with.
Okay, and then second is, are there any progress with facial capture? I noticed you had all the markers and stuff on your body, but I didn't see very much for face.
Okay,
for previs or
so
anything like that.
the face stuff kind of is similar to the quadruped question. Like, they're just treated as another source of data coming in. So we have like Dynamics is, we said the French mocap company, their facial mocap, and they stream in real time. Faceware are working on a solution at the moment. We added in the last version of the engine the iPhone 10 AR stuff, which was what the baby demo from Real Time Live was using from Kite and Lightning. So all of that still comes through LiveLink, But at the end of the day, it's just treated as, in the iPhone X's case, 51 curves. And then you can choose how to apply those curves. If you have the same blend shapes, you can just map them directly onto it. But maybe you need to do some extra processing, and you could do that in the animation blueprint and then apply it to your character. So there's nothing bespoke specific, but we have facial providers coming in. And the same way I was doing that layered blend to get the character animation blended with the mocap data, it means I can also blend body data with face data. And that's what we did on the Siren demo at GDC, if you saw that.
Okay.
It's also at our booth. Her body is from Cubic Motion. Her face is from Cubic Motion, and her body is from Vicon. And then I'm layered blending them together.
That's really cool. And then my last question is, earlier you said you guys are still working on recording within the engine.
Yes.
So how would you bring motion capture animations and bring them into Unreal?
At the moment, I'd just use an FBX.
Okay.
Like, if you want to still be able to work with that data, I'd use an FBX. If you've done some retargeting, say in Maya, and you're doing more complicated stuff like vertex deformations and delta mush, like at that point you'd probably want to bake out an alembic and bring that in so you've got the geometry cache, because that would be doing things that the engine can't handle. But generally FBX is kind of the most feature complete, at least at the moment. We are exploring other formats.
Like USD and stuff like that?
USD, yeah, but USD at the moment, USD is a scene description format, and we're leaning more into the scene description side than the geometry format. So being able to export the scene, preserve how things are laid out, being able to do overrides and changes. So yeah, so that's more where USD is. Geometry is, we'd still go FBX or Alembic at the moment.
Right. Thank you.
Yeah, no problem. I think there's hands over there, so feel free to
you
throw
catch?
at people.
So you said you wrote your own timecode system, or did you use? Can you use the timecode signatures coming in from the capture data?
Yeah, so you use basically when you stream the data in through Live Link, there's just a F timecode variable, and you just populate that.
Okay.
And then the engine will pick that up and use it. And it's standard hours, minutes, seconds, frames, subframes. And then timecode. And we support, timecode is done as a fraction, so we can support all the weird NTSC formats like 2997, and we can get those exactly.
Great. Non-drop.
Well,
I'm just joking. It's okay.
we can do drop, but you kind of have to convert drop to non-drop.
Okay.
But at least to your left.
We're using live action, OptiTrack, and 6 rigid bodies, points of track, and a prop like Blaster. Ikinema doesn't have a lot of information on how to deal with those extra animations of, say, snapping the fingers around the prop, or the physics skeleton on the ponytail type thing. Just wondering if there's a place to go to kind of see good ways to do that type of thing.
For the physics-based animations, I strongly recommend checking out the Paragon characters that we released. We recently updated them to have animation blueprints. They're more gamey animation blueprints, but a lot of them will have a chain of bones and doing rigid solves on the bones to do hair or belts. So for that, there's a lot of information there. And that will also have things on a two-bone IK system, snapping, because they'll be doing things like holding guns. So you need to make sure that the hand is at the right bit of the gun. So they're warping the animation to make sure things match when they're playing their ability effects. That's probably a really good place to start. I don't really know of any other than our documentation pages. We actually recently updated, you may not have seen because you've been at SIGGRAPH, but about yesterday, I think, we went live with it. If you go onto our website and go to the Learn resourcing on video tutorials, we've revamped all of our video tutorials into this, we're calling it Academy. So it's academy.unrealengine.com. And they're more class focused and more discipline focused. So rather than before where it was let's make a game, it's now, I'm an animator wanting to learn this feature. I want to get better at lighting in Unreal. And we'll have sort of these more structured, short video courses, maybe 12 videos, taking you through these specific facets of the engine rather than kind of trying to do everything as one big project. So I'd recommend checking out that as well. There's been a lot of really good work there.
Cool.
Oh, I am massively over time. So yeah, I'm going to wrap up here, but feel free to grab me and I will happily talk.